Okay, now let's talk about contingency table. Okay, using data from statistics class, data was connected on whether students like chocolate and whether they like espresso. Okay, now take a look. What's the 11 means? 11 means there are totally 11 students who likes chocolate, also likes espresso. So this 7 means there are 7 students who likes chocolate but doesn't like espresso. That's how you read the table. So what's that total means? Total means there are totally 18 students like chocolate. We don't care whether they could be like espresso or doesn't like espresso. So look at these 15 or 8 means. This A means, look at here. This part means there are totally 8 students among the 23 doesn't like espresso. So among these 8 students, 7 of them like chocolate, but 1 of them doesn't like chocolate. Okay, that's what the table means. Okay, so they ask you what's the proportion of students likes chocolate. So now take a look. Student who likes chocolate is in here. So the total number of students like chocolate is in here. So we know that, hey, there are 18 students who likes chocolate out of totally 23 students. So the proportion you should look like student who likes chocolate over the total student. And if you need to reduce to the simplest form, but 18 over 23 is already the simplest form. Okay, so now what B is asking you, what are the proportion of students do not like espresso? Okay, so now let's find out what student doesn't like espresso. So doesn't like espresso. So we need to find out the total number of students who doesn't like espresso, which is 8. Okay, so that means we have student who doesn't like espresso over the total number of students, which is equal to 8 over 23. Okay, so they also tell you that these are marginal probability because we use the number in the margin, the use of the total number for a single variable. Okay, now join probability. What are the proportion of the class like espresso and the chocolate? So let's find it on the table. They need to both satisfy. They like espresso. Also, they need to like chocolate. So let's see which part is overlap. It's here, right? So that means there are totally 11 students who like espresso and the chocolate over the total amount of students, which is 11 over 23. And now the next question is, what are the proportion of the class doesn't like espresso and doesn't like chocolate? Okay, so let's find out. Doesn't like espresso and doesn't like chocolate. Oh, only one. Not surprised, right? So we find that the student doesn't like espressos and the student doesn't like chocolate over the total amount of students, which is 1 over 23. So this is called joint probability. That means they need to satisfy both conditions or the condition that they overlap. So the other one is conditional probability. Okay, what are the proportion of students like chocolate, also like espresso? So that's a little bit different because we're looking for students who likes chocolate and then also likes espresso. So first of all, we're not looking for the whole class student. So that means we're not looking for the total amount of class who likes espresso. We're more looking for the student who likes espresso over the total amount of student who likes chocolate. So let's take a look. So the total amount of students who like chocolate is in here, right? There are 18 students who likes chocolate. Among those 18, we need to find who likes espresso, which is the 11, right? So there we have 11 students who likes espresso, who also like chocolate. So it should be 11 over 18. Okay, that's conditional probability, which is given. So we can, in a word, say the probability equals to the student they're trying to find the student who like espresso, given that they like chocolate. So that means on top of here, they're not just like espresso. They like espresso and the chocolate, given that those students who likes chocolate. Okay, that's it for today. Let me know if you have any other questions.